Swayam Prabha. Digital India. Educated India.
Welcome to this sections on emerging. Wait, okay.
It's at the top, sir.
Huh?
It's at the top.
It's away. Okay. Emerging application of AI. AI has become a very exciting topic of research, and we look forward to a presentation by the authors. The first paper will be from University, South Korea, and the presenter will be Lee, right? Yeah, instead of Street. Okay. Please start.
Hi, I'm Lee. I'm from Korea and I'm a graduate student in university. Today I present about the technology-based cluster sequencing and MINRP for high feasible, fluidity, and optimal last mile delivery route generation. I will present follow this online. First, I will presentation about overview, the last mile delivery, and traveling salesman problem. And I will introduce prior research about local search and the known best solution, the Lincolning and Haskell algorithm. And next, I will introduce Amazon last mile route research challenge. It provides a real world data about TSP. So next, I presentation about the proposed method. It has a 4 steps about the energy consumption calculation and with object function and the journal ID and the optimization. And I present the result and conclusion. First, last mile delivery means the final step of delivery to the end customer. It is very important in these days because the size of the global e-commerce market is growing every year. So last mile delivery also very important in these days. And the last mile delivery is also the most inefficient part of the current logistics process, and the cost of the process accounts for 53% of the total logistics process. So the last mile has great meaning for both customers and the suppliers. The consumers are the first to form a user experience with a company in the final delivery stage, and this user experience has a great impact on their loyalty to the company. And the efficient last mile delivery for suppliers achieves the cost minimization, and they get to acquire loyal customers. We can say the last mile route optimization can be defined as a kind of TSP, the traveling salesman problem. TSP is a problem of generating routes that is all cities want at the minimum cost. So in the past, fast and damage-free delivery was important, but now it is necessary to create an optimal delivery route that takes into account all of the reduction in delivery time or cost optimization or customer requirements. So, but however, the time complexity of TSP is very large, so therefore many studies have been conducted to solve the TSP using a heuristic method. And I introduced the local search. The local search is a heuristic technique for solving difficult to calculate problems. It is a method iteratively finding a better solution from the current state. So, you know, the genetic algorithm or simulated tunneling is the local search algorithm, and therefore the similar answer to the optimal solution is derived using a heuristic method rather than the mathematical optimal solution, because the time complexity is very large. And here is the 2 opt and 3 opt example of 2 opt and 3 opt is here is a 2 opt and 3 opt example. This is an edge swapping algorithm. You can see here the dotted line is very twisted line. So unlabeling the twisted line is the basic concept of this edge swapping algorithm. If you choose two random lines, it means two opt, and you choose three lines, it means three opt algorithm. And the Lincolning and Haskell algorithm, shortly LTH algorithm, is one of the best algorithms for TSP. So the use of two opt and three of the several times is called k-opt, and the LTH algorithm is based on k-opt. And LTH algorithm uses clustering method because the logic problem to solve a logic problem. First, they divide the large problem into multiple regions like this figure, and optimal route is generated based on k-opt. After k-opt, the device structure is merged like this, and k-opt is performed again on the merged tree to make the global optimal solution. We choose the Amazon challenge. Amazon and MIT held the Amazon last mile routing challenge from in 2021. The researchers have never been given such a large data about the real-world TSP problem, so it's very meaningful for researchers in this field. The Amazon provide the data like this, and the provided data is divided into two categories: the model build and the model application process. Model builds mean the training the data, and model application means that test the data set. So the data is we use these three data, and first is raw data. It means geographical information about the delivery stop. For example, coordinates or where is the start point, and the zone ID. It will be interested in the next slide, and actual the delivery line. And travel times means the travel time between some delivery points, and the package data means the package size, etc. Package information like the package size and the etc. And this is the core function of this challenge. This core function is lower the best function. And A means the actual delivery route, and B is the proposed optimal route. And SDAB means deviation between A and B delivery routes. ERP no means the travel time penalty. And ERPC is number of bit difference between A. So you can see in this score function, one of the challenge is not to find shortest tour, but rather to find tour closely matching routes taken by experienced Amazon drivers. Easily say our proposed route is have to similar with actual routes. And we use the energy consumption for the high visibility for actual routes. So we use energy consumption is derived from the count kilometer method. It is energy consumption defining method, one of them. So energy consumption is defined as transport weight multiplying by transport distance. However, we use the volumetric weight method to estimate weight because the Amazon challenge only provides a dimension of the product strip. And because of the score function provide the challenge imposes a penalty based on travel time, the transportation amount was calculating using the travel time instead of distance. So here is our proposed modified energy consumption. It means volumetric weight multiplying by travel time. And our object function is as follows. This is very similar to basic TSP. In this formulation, we use the TIJ, the travel time multiplied by package volume weight. We multiply that, and we get an n value, the substitute the last number to set priority when visiting different zones. That's just a zone of zone ID. It is very important point about our research. So we found that consecutive delivery points have the same zone ID. That means delivery points are sorted by zone ID. You can see the real package about a package for Amazon. You can see the zone ID here. Each zone seems to be set based on distance, and the study was conducted assuming that the zone ID acts like a postcode, indicate the kind of region. Here is the example of a zone ID. And we found the zone ID sequencing rules. The entire zone ID can be said to be a symbol representing clusters of different sizes. A is the largest cluster, and 0 is the next, and the B is the next, and 1 is the smaller cluster. When moving to the next cluster, the number of positions of 1 and B has a specific pattern. If the previous cluster proceeded in order of 1 to 3, the next cluster proceeds in order of 3 to 1, like this. And you can see the zone. Each zone represents the different color, and the same color means same zone. So you can see the right. You can see the actual sequence of zone ID. You can see the rules E and D, C, B like this, and 2, 1, 2, 3 like this. But you can see in AMG 003 cases, it's not followed our rules. The rule is not always followed, so therefore we want to extract the zone ID sequence from the actual delivery route in the past. So our extraction of zone ID sequence is like this. We use 6,100 passes routes using 20 pace, and the other 13 passes using offline pace. There is no zone ID, replace it with a zone ID of nearest stop. Because you can see the zone ID base or zone ID cost of nearest stop. Previous sequence existing for a screening route, the most repeated sequence was selected, and if there is no previous sequence, the zone ID sequence is extracted by applying the sequencing rules we mentioned before. Figure on the right show our zone ID and zone ID visit order of each point. And we make a weighted travel time matrix for using the volumetric weight. We define the energy consumption like this: travel time multiplying the volume weight value. We use the volume weight of the delivery item at the stops, subtract by the total volume weight. We use this value. We multiply the travel time. We define the energy consumption. You can see this is Amazon provided travel time matrix, and here is our wait time matrix. So we use the Google OR tools to minimize energy consumption. A local search was performed based on Google OR tools and minimize energy consumption. So because OR tools can easily reflect time windows and use routing models. And the result is here. You can see the table. When route was created using only clustering, using the right constraints, the average score is 0.01. But however, the score improved when clustering weighted our proposed method used. And you can see the existing best solution is 0.01. We can show the better performance. And you can see the actual delivery route here, and here is our proposed route here. You can see the very similarly both. And here is the table, and we can show your score. The feasibility means this feasibility and the delivery time and the energy consumption like this. We can show the blue things is the better than non-best solution, and the red is the LKH is better than our solution. Let me address this about LKH AMG. It seems to be focused on reducing travel time better over hours. The LKH AMG model also use the zone-like constraints. They follow the rules and they reducing the travel time. So, the score of LKH AMG only find the shortest travel time was 0.07. When using LKH AMG, model included the zone-like constraint was 0.01. We show the best score in this challenge, and LKH AMG, the best solution as of so far, creates a route that minimizes travel time, and it shows feasibility is obtained by following pre-specified zone-like sequence. The proposed method minimizes the sum of volumetric delivery time of packages and determines the priority of the visit by considering clusters made from zone-like sequence. And compared to LKH AMC, the best solution, our proposed method showed the reduced energy consumption by 9% and improved delivery feasibility by 40%, with only one increase of the total travel time on average. Although the proposed method could generate routes with higher feasibility, there was a certain case where LKH AMG scored better because both methods failed to generate good feasibility routes, and the score of LKH AMG result better when multiplied by travel time penalties.
Thank you. Questions from the floor? We check any questions online. I have a question. You talk about the comparison with the existing model.
Yeah.
So, what type of modifications or what new ideas that you have proposed? It seems that your model focus on energy rather than time.
Yeah.
So, was the energy considered optimization in the original model, or did you just consider time, or did you both consider time and energy as a variable of optimization?
We consider both time and the energy.
Right.
We use the volumetric rate.
Right.
We reduce the people. So we use the value multiplying the time.
Yeah.
So we define the energy consumption.
Okay.
We minimize the energy consumption. So
the energy consumption is a function of time.
yes.
That's why you are saying that optimization with energy is a much better option, right?
Yes.
Thank you.
So what kind of variability you see in terms of the package volume? You said instead of weight, you started using volume to compute the power, right? So what kind of variability you see across the packages? So in terms of volumes of the packages, are the volumes of the packages more or less the same, or there are huge variability in the packages volumes?
Actually, the volumetric rate is used in delivery company like Amazon because the weight is not weight is just if there is a light and the density is very large package, if there is a packaging like that, it cost is expensive, if you understand.
Yeah, I understand that. My question is, let's say you have 100 packets, 100 packages,
Yeah.
and these packages differ in volumes. And what is the variability you saw among the 100 packages in terms of volumes?
Maybe we'll leave the discussion after the session.